All right, so let's go ahead and talk about pressure. So this is going to be how we measure one of the properties of a gas. So it would be extremely difficult to measure the mass or the number of molecules or the moles of a gas. So we need to be able to quantify how much gas there is. So we do that by measuring the pressure. And the pressure is defined as the force exerted per area. So what you would want to think about is if you have a closed container, so if we have a container here, and then it has a lid on it, and then if we put a gas in here, it's going to be exerting a force on the sides of this container and the lid. What we mean by that is if you were to consider a given area, and then we were to consider like column of air, okay? So there's going to be, the gas is going to be exerting a certain amount of force on this given area right down here. So again, like I said, we can't really measure the mass of a gas readily. So we're going to measure the pressure. So pressure is equal to force per area, and force we can replace with mass times acceleration due to gravity, and eventually whenever you guys take physics, you'll learn that this is G in physics. But let's go ahead and try to calculate the pressure for a few different problems here. So whenever we are measuring the pressure, if we're using SI units, force has units of newtons, and a newton is a kilogram meter per second squared. And we tend to measure, because recall that pressure is force over area. We tend to measure pressure for SI units would be pascals. However, we tend to use atmospheres in most of our problems, but we will get a whole list of conversions going between the different units of pressure. So let's go ahead and try to figure out how much pressure does a penny exert on your fingertips. Okay, so again, we know that pressure is equal to force over area, but check the units on this really quick. Okay, so for force, we said that that could be mass times acceleration. Okay, so A would be a constant, but we need to get our mass in terms of kilograms, and whenever we're talking about our area, that needs to be in terms of meter. So the first thing that we need to do is to convert our mass from milligrams to kilograms. So mass is 10.2 milligrams. Okay, then for every 1 gram, there are 1,000 milligrams. And then there are 1,000 grams in a kilogram. So we end up with 0.0000102 kilograms as our mass. And then our area, we need to convert to meters squared. So we'd start out with our 1 centimeter squared area that the penny occupies. Convert that to meters squared. So there are 100 centimeters in a meter. We'll need to square that. So we end up occupying an area of 0.000100 meters squared. All right, so we're ready to plug into our equation for pressure. So the pressure that the penny is exerting will be, so we'll plug in our mass. Multiply that by our acceleration, 9.81 meters per second squared, and this is a constant that we would use. And then divide that by the area in terms of meters squared. So whenever we plug this in, what we should get is that our pressure is 1 kilogram per meter second squared, which is also equal to 1 Pascal. Okay, so we know how little pressure a penny exerts on our fingertips. So let's go ahead and get some perspective for how much pressure the atmosphere actually exerts. So let's go ahead and think about this. We want to calculate the atmospheric pressure knowing that 1 meter squared column of Earth extending from the Earth's surface through the upper atmosphere has a mass of 10,300 kilograms. So what we go ahead and say is, let's pick a point on the side of the Earth. Okay, so this is at sea level right here. And then if we were to take a column and extend it all the way up into the upper atmosphere. Okay, so this is our atmosphere up here. That if we were to isolate all of the air that's in there, that it would have a mass of 10,300 kilograms. All right, so again, recall that the pressure is equal to force over area, and we can substitute in for force, mass times acceleration. So let's calculate what the pressure is, what the atmospheric pressure is. Okay, so for us, let's go ahead and add a few more sig figs here. Let's make that 1.00 meters squared. So we're ready to plug in. Okay, so we'll have the force, which we'll use the mass. So we'll have 10,300 kilograms times the acceleration due to gravity, which is 9.81 meters per second squared, divided by the area, which is 1.00 meters squared. What we'll end up getting is 101,000 pascals, which is also equal to 101 kilopascals. Okay, so this would be like taking 101,000 pennies and stacking them on top of each other. That's how much pressure the atmosphere is exerting down on Earth's surface. Okay, so we'll actually see here in just a little bit that this is really close to the conversion factor going from atmospheres to pascals. So let's go ahead and go over some of these common units that you'll see for pressure. Okay, so some of the units that we'll see are millimeters of mercury, or torr, and typically you would measure the atmospheric pressure using a mercury barometer. And what we'll see here, a barometer works like this. So you have an inverted tube here. This is a vacuum up here. This is filled with mercury. And as the atmospheric pressure varies, depending on how much it's pushing down, what force it's pushing down with, the height of this column will fluctuate up and down a little bit. And then you could go through and measure the atmospheric pressure for the day. So if you're ever watching the weather on the news, it will give you a reading, typically in inches for what we're watching, but it will give you a barometer reading like that. So we will use all of these units and be able to convert between them, but here are some of the equivalencies. That 760 torr is equal to 101,325 pascals, which is also equal to 1 atmosphere. This will be the unit that we tend to use the most, but we need to know how to convert between all of these. In Europe, they tend to use bars. And a bar is actually a little bit easier for conversions because it's based off of 100,000 pascals or 100 kilopascals, whereas an atmosphere, the equivalency is 101,325 pascals. But I will give you all of these conversion factors. You just need to know how to actually use them. So let's go ahead and try a few conversions, see if we can still do those. So let's go ahead and consider that the typical atmospheric pressure on top of Mount Everest is about 265 millimeters of mercury. You'll also see this written as 265 torr. I will go between these two all the time. So what we want to do is we want to convert this value to pascals, atmospheres, and bars. So I have the answers right here. So I'm going to set up the first one or two with you, and then I'll let you solve the last one by yourself using the conversions from the previous slide. So what we want to do is we want to start with 265 torr. Okay, now we need to convert the 265 torr to pascals. So using one of our equivalencies on the previous slide, we know that there are 101,325 pascals for every 760 torr. So torr will have to go in the denominator, so our units cancel out, so torrs cancel. We'll be left with pascals. You should get 3.53 times 10 to the 4th pascals. All right, let's go ahead and try to convert this to atmospheres. So again, you'd start with your given, which is 265 torr. And now we need to convert this to atmospheres. So in 1 atmosphere, there are 760 torr. Whenever we plug this in, we should end up getting, after our units cancel, because torr will cancel here, we should end up getting 0.349 atmospheres. So why don't you guys go ahead and try to convert this to bars and make sure that you get 0.353 bar.